Welcome to Eureka Math. I'm Mr. Shankel. I'm going to help you today get ready for your end of Module 2 test with the Module 2 review. Let's get started. The first thing we're going to start with is division using a standard algorithm. So I'm going to give you a problem number 1 from the review today, which was 210,453 divided by 14. And remember that the first number in the division problem goes inside the division symbol. So I have to use some estimation skills here. How many times does 14 go into 21? I'm going to say that that is 1 time. So let me change colors here. 1 time. 1 times 14 is 14. Subtract, and I get 7. And then I'm going to bring down the 0. So I'm just following the division algorithm. Divide, multiply, subtract, bring down, do it all over again. So 14 into 70, that is 5 times. 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 1 is 2. So that's 70. Subtract, I get 0. Bring down the 4. Now this is where sometimes we make mistakes. 14 doesn't go into 4, so you think, well, I got to bring down the 5. But first you have to answer that question. How many times does 14 go into 4? And the answer is 0. So 0 times 14, we're just following the algorithm. Subtract, get a 4. Now I'm going to bring down the 5. 14 goes into 45. Well, 15 goes into 45 3 times, so I think it's 3. 3 times 4 is 12, carry the 1, and 3 times 1 is 3 plus 1 is 4. And subtract again, I get a 3, and you're going to bring down the 3. 14 goes into 33 2 times. 2 times 14 is 28. Subtract, and you get a 5. Ran out of room. And I don't have an answer yet, so I'm going to add a decimal, and a 0, and I'm going to bring it down. So this is 50. How many times does 14 go into 50? Well, that's 3 times again. 3 times 14 we already did was 42, so I'm going to move this over here just so you can see it. 50 minus 42, and that's an 8. And then we would add another 0 and bring it down. That would end up landing right there. And then 14 into 80, well, that's a 5. And 5 times 14 is 70. And I would subtract and get a 10. And I would add another 0 and bring it down. And that would land right there. And I can just keep going and going and going and going and going. If you get this on the test, then just round it to the nearest tenths or hundredths place. Tenths is fine. I would round it at the tenths place. The decimal goes straight up into your answer. And so now, if I'm going to round, let me get my highlighter. If I'm going to round this 3, then I need to look at the number directly behind it, that 5. And the 5 tells me to round this up, the 3 up. So my actual answer is going to be 15,032 and 4/10. I'm going to round this up to 4. Okay, division algorithm. You just got to keep following the steps. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Keep going until you get your answer. Next was division with the decimal. And what I want to point out and remind you is that you cannot divide by a decimal. So this problem, 118.2 divided by 1.2, right now can't be done because I cannot divide by that decimal 1.2. So I have to change this. First of all, let's write it as if we were going to do it. 118 0.2 is the first number that goes inside, divided by 1.2. I cannot do this, so I'm going to change it so that it allows me to divide. If I can't divide by a decimal, I'm going to make it not a decimal. So move the decimal to the end of the 2, the 1 and 2, and that makes it a whole number 12. Now I can divide. But if I move that decimal, I have to also move the decimal in my dividend. You're essentially multiplying by 10, which creates an equivalent fraction and allows us to actually do the multiplication. So the way that you will be able to do the division would be this. Your new problem would be 12 into 1,182. And you can use the division algorithm to solve for your answer. So the thing to remember about dividing by decimals is you can't divide by a decimal, so you have to change it into an equivalent fraction that has no decimal in the divisor. It has to be a whole number, and that would be right here. Okay? So, division algorithm, division with decimals will both be on the test. The next thing that we talked about was GCF, greatest common factor, and least common multiple. If I want the GCF of two numbers, let's say I want the greatest common factor of 12. Wow. Excuse me, I'm on the wrong tool here, so let me change. 12 threw me off because the 1 worked somehow. GCF of, let me start again. I want the GCF of 12 and 18. Okay? GCF of 12 and 18. I have two different ways that I can do this. I can make a list of all of the factors of 12 and all of the factors of 18. So 1 times 12, 2 times 6, 3 times 4, 4 times 3, but I already have it. 18 would be 1 times 18, 2 times 9, and 3 times 6. And that's it. So the GCF of 12 and 18, well, the C stands for common. What's the common factors? Well, I would find the common factors by just comparing the lists. There's a common 1. Here's a common 2. There's a common 3. And there's also a common 6. Okay? Of those common factors, which one's the greatest? Well, it's easy to see that it's the 6. So that is the greatest common factor. The list method is great if you don't miss a factor. In this case, if I would have not remembered that 3 times 6 is 18, I wouldn't have had any of this, which means that I wouldn't have seen that 6 is a common factor, so I wouldn't have called it the greatest common factor. And this 3 wouldn't be here. This 3 right here wouldn't be here. So I wouldn't call 3 the greatest common factor because there would have been no 3. I might have said the greatest common factor is 2, but we can see that that's not true. So the list is fine if you are thorough and don't miss something. I think this is a better way. It's called the prime factorization. Just find ways to multiply to get 12. 2 times 6. 2 is a prime number. 6 is 2 times 3. These are both prime numbers. Look at 18. 18 is 2 times 9. 2 is a prime number. 9 is 3 times 3. Those are prime numbers. Find what's common. Well, this 2 matches that 2. And this 3 matches that 3. So my common factors are 2 and 3. If I multiply them back together, I find that the GCF is 6. Part 2 coming up. Make sure you tune back in to find more answers. See you then.